Hello, it's dumplet here. Here's an item on trigonometry. Find the minimum value of 2 cosine squared x plus 8 secant squared x plus 18 cosecant squared x plus 2 sine squared x plus 1. Credits to the Art of Problem Solving community for this item. As usual, pause this video if you'd like to give this item a try. But if you're done, let us dive into the solution. Now, my approach to this problem, whenever I see a lot of cosines, secants, cosecants, I more or less try to make it into like one trigonometric function because it's easier to work with. Technically, I'm only dealing with like a single variable in, for example, a polynomial equation or a polynomial expression. So let's try to do that. So first we can change the secant and the cosecant to one of our cosines and one of our sines because it's easier to work with sines and cosines. And as you can see there, in the blue underlined cosine squared x, I'm using the Pythagorean identity to rewrite cosine squared x as 1 minus sine squared x. And now my resulting expression over here, as you can see down here, it's just an expression in terms of sine x, or sine squared x, however you like to call it. And we can write this a little bit nicely because, for example, if I let u equal sine squared x in this expression, I would be able to get an expression in terms of u. So 2 times 1 over u plus 8 over 1 over u plus 18 over u plus 2u plus 1. And essentially we're just trying to get what's the minimum value of that. What's the minimum value of this? So let's try to not consider that u equals sine squared x. Let's just try to get what's the minimum possible value of this expression over here. So I'm going to convert it into a rational expression, as you can see here, and we're going to take a look at the range of values of this expression here. So let y equals 18 minus 7u minus 3u squared all over u minus u squared. Now, a very easy way to get the range is to use the discriminant method because, as you can see here, I can manipulate this equation into this form, and this form is going to be familiar. It's just quadratic in terms of u, and although we have y there, and that's going to tell you a lot of nice things because we know that x must be a real number. X is the variable here. So if you want x to be a real number, then the discriminant, as we've learned from high school, the discriminant of a quadratic equation with real roots must be greater than or equal to 0. So we have here y plus 7 squared minus 4 times y minus 3 times 18. That should be greater than or equal to 0. And all we have to do is solve for y there. Now we're just considering that u is just technically a random variable. We're not really considering yet that u equals sine squared x. So anyways, we're going to solve for y, and that's just simple quadratic inequalities. So simplifying, it's going to be y squared minus 58y plus 265 is greater or equal to 0. We can factor the left side over here. It's nicely factorable to y minus 53 and y minus 5. So this will be greater or equal to 0, and we would be able to get that there are two solutions here, two ranges of solution. Y is either less than or equal to 5, or the other cases where y is greater than or equal to 53, and we're going to take a look into both of these independently. So let's try to focus on the first one. Y is less than or equal to 5, because we're asked to get the minimum value of y, and if that is equal to, if that's true, then the given expression here doesn't have really a minimum value. But we can disprove this case really easily because we can apply the arithmetic mean, or the AM, and then geometric mean, or the GM. So we can apply the Amgm inequality into this part. So for example, in the first two terms, by using the Amgm inequality, we will be able to get that 2 cosine squared x plus 8 over cosine squared x, that must be at least 2 times the geometric mean of 2 and 8, and that's going to be equal to saying, okay, this first two terms, they should be at least 8. Their sum should be at least 8. And then similarly apply this to the third term and the fourth term over here, using Amgm inequality. That will be greater than or equal to 2 square root 18 times 2, and you guys can simplify. It's going to be greater than or equal to 12. Well, we don't really know about whether or not these equalities are attainable, but from the Amgm inequality, this entire thing must be greater than or equal to 21. So here, if we get the y less than or equal to 5, that's going to not be considered. And that's kind of obvious why, because, well, this is just the value of y we got in terms of u, where we didn't really consider that u was sine squared x. But anyways, we will be able to disprove y is less than or equal to 5. So let's try to move on to the other case that we got, where y is greater than or equal to 53. And here I'm going to make a claim. I'm going to claim that y equals 53 is indeed attainable. And that's going to be like the thing that you have to check, because yes, you got that y is greater than or equal to 53, but maybe y cannot be equal to 53. So if you want to just double check your answer, or if you want to supply a proof that, well, y can be, the minimum value of the expression at the start is indeed 53, so let's try to check it. So if y equals 53, I'm just going to substitute y into this equation that we know it should be true. Alright, because that's just the manipulation from this part, so we just let y equal to this, and then we're technically just substituting y equals 53 here, and then checking for the possible values of u. So as you can see here, if y equals 53, again we can actually get a quadratic that is nicely factorable. 50u squared minus 60u plus 18 equals 0. You can factor that as follows. 2 times 5u minus 3 quantity squared equals 0, and that's going to give you u equals 3/5. And again, this is just the value of u, so we kind of have to check whether or not there's a value of x at the start. And since we made the substitution, u equals sine squared x. Sine squared x is equal to 3/5. We can actually get a value of x. We don't really care what the value of x is, or like what's the value of x, but it is for sure, it is certain that it exists, because the sine x, it's the sine squared x, it has a range from 0 to 1. So 3/5 is in that range, so we are guaranteed that there is a value of x. Alright, so we got y is greater than or equal to 53, and we were able to check that there is indeed a value of x that makes y equal to 53, and therefore the minimum value of the long trigonometric expression at the start must be equal to 53. And this will be our final answer. Hopefully you guys learned something new from this video, and I'll see you in the next one. Bye bye!